Hi.
Well, thank you so much for being here today at this awesome panel with some amazing, distinguished guests, proactively building resilient infrastructure. So what great way to start with one of the original infrastructure idea builders of young minds and some Lego. So today I have the privilege of having some young future engineers and artists. I have a spear from John Canyon here just to get the mind rolling, and I have fire from my daughter Arabella, who's back there in the back, and my son Apollo. I'm not sure exactly what he meant, but it looks really cool. But super sturdy, but also very fragile. And so a great way to segue with three folks who've been working on this space for many years and come from very different backgrounds. And so first I'm going to start off here with Pat, with each of you, just go down the line. Just talk a little bit about your company, what you do, and maybe just a little bit how you got to where you are today. I think just give some context for the audience.
Sure, my name is Pat. Good afternoon, everybody. I'm an electrical engineer by training and trade. I started in nuclear power, but I spent most of my career in T&D, in engineering, obviously. But I also ran operations for 8 years, and when I stopped working for the utility, I was in executive leadership. But it was really my technology projects in the middle of those assignments throughout my career that led me to work for ESRI, or as we used to say back in the day, ESRI. And I think it's probably useful to recognize that name itself encodes an awful lot. And ESRI, for those of you that are not familiar with the company, ESRI is used by most utilities in this country and many around the world to map and manage their systems. And so ESRI stands for Environmental Systems Research Institute. Is that a new bit of information for anybody? It's got to be. Well, the name will tell you that we're a very environmentally conscious company and a socially conscious company. But what I found interesting when I started to work there was the research element. I don't know what our numbers are. Our sales numbers will be between 1 and 2 billion worldwide this year. And 30% of that goes back into research and development. Much of that development goes into modeling, as Hohl alluded to, related to utilities, because almost all utility infrastructure has our system as a system of record, and then becomes useful to employees and other systems that need that information. So in my role in industry solutions, I really connect ESRI with this industry because I'm a subject matter expert in the business. Utilities represent the second largest industry for the company, the largest being government, but utilities are second to that around the world.
Howdy, everyone. Alice Jackson. I am the Senior Vice President of System Strategy and Chief Planning Officer for Xcel Energy. What that means is I have the responsibilities for all of the planning functions inside of the utility. We're the first utility in the nation to combine and remove from all of our verticals, transmission, distribution, energy supply, and gas, all of the planning functions, and combine them into one organization so that we can cross-functionally meet the needs of the long-term energy delivery system of the future. If you're unfamiliar with Xcel Energy, we're a vertically integrated investor-owned utility that operates in 8 states, generally in the central US. So the Upper Peninsula of Michigan, over to Wisconsin, Minnesota, North and South Dakota, Colorado, the Panhandle of Texas, and New Mexico. So we're outside of the ERCOT region. My background, it does not include utilities for the entire time. I started as a computer software programmer, programming shadow settlement systems for electricity markets and Monte Carlo simulations for trading organizations and applications for natural gas liquids. I was in the oil and gas industry, started off in a little-known company called Enron, got laid off with 3,000 of my closest friends, and then was very fortunate to be picked up by Occidental Petroleum for about a decade before I went over to Xcel Energy. The way I got to Xcel Energy is I used to intervene in their utility rate cases. And about 13 years ago, the general counsel of the company called up and said, instead of taking them apart, how would you like to put them together? So I went from being in the oil and gas industry over to the utility industry, where I had the opportunity to learn it from the inside out once again. So Background ranges from IT programming and learning the industry, from programming shadow settlement systems of ERCOT, so started in Texas, then moved to the New York ISO, the SBP, and the MISO. So a wide variety of trading applications, markets, and operations that ultimately ended up in serving at Xcel. At Xcel, I did regulatory for a long time, then I was the operating company president in Colorado. And now I have the opportunity to figure out with a very large team of engineers of how are we really going to do this. As the first utility in the nation to also announce getting to a zero carbon system by 2050 on the electric side of the business and a net zero carbon system by 2050 on the gas side of the business, that's a real problem. Because when we made that announcement in 2018, we knew, number one, that we didn't have all the answers. Still don't have them today. What I can tell you is I'm really proud that we're making some tremendous progress. I know we're going to get into some deep conversations here about how do you move that forward. But right now, the plan that we have approved in Colorado will take us to more than 80% of the energy that our customers consume in calendar year 2028 will come from a renewable resource. That's a pretty incredible feat to overcome, especially with the size and diversity of the system that we have, ranging from densely populated areas like Denver metro region to the very rural areas of eastern and western Colorado. So a lot of pieces to that puzzle. Look forward to getting into it here a little bit today.
All right, thank you. Am I on? Good, okay. Thank you. Always wonderful to be at ETS and back in Austin. Emeka, Anyanwu. I'm now with Lincoln Electric System. So I just started as CEO there at the beginning of the year and rapidly sort of trying to get my feet under me. And so my path has taken a little bit of kind of an interesting path. I've sort of moved progressively to smaller organizations, which has been a kind of an interesting experience. I started my career, I'm an electrical engineer, much like Pat, by background. I started my career doing distribution side engineering, distribution planning, and customer engineering, working customer projects, a variety of different stints, everything from managing, supervising design technicians to I put on boots and supervised line crews for a couple years. So really grounded in the operational side of the business, as I like to say to folks. I didn't never climb poles for a living, but I did get my fair share of mud on my boots. And from there, I went to Seattle City Light, which is a municipal, one of the largest municipals in the country, up in Seattle, Washington. Worked there for a few years prior to coming to LES. And when I was in Seattle, I was doing a lot of work around transformation, around the future of utilities, both the business and operational side of things. And so, a lot like Alice, I spent a lot of time really thinking deeply about how we are going to make a transition, not, again, just as you think about, obviously, sort of the technical elements of a grid and a supply system that needs to transition, but really sort of a whole community that needs to transform around that. And really that is maybe one of the unique elements of public power, particularly municipal utilities, is the ways in which we are ultimately tied to the greater community infrastructure and the ways we have to think about that. So we'll talk a little bit about sort of what we are. Lincoln is kind of a big small town. So if you're not familiar with Lincoln, Nebraska, Lincoln is the state capital of the state of Nebraska. I'm not going to say go Cornhuskers because I'm a dyed-in-the-wool Iowa State Cyclone, but I knew somebody would help me out there. So just shy of 300,000 people in the city of Lincoln and our service territory. Just shy of almost 150,000 metered customers, most of whom are residential. About 130,000 of those are residential. And so, we are small enough, obviously, that there are certain things that are beyond us in terms of just our scale, but we are big enough that we start to see some of the beginnings of some of those scale issues, and then we are tied into a greater city infrastructure where we have an active sort of climate action plan that the utility is deeply tied into. So look forward to talking about that. A lot of that is based on this concept around climate resilience for our community, and looking forward to digging into that here.
Thank you. So we'll just jump right in on decarbonization, because this is something all of you work on, and maybe the starting points of where you're at now with it there. And maybe, Pat, I'll start with you, and maybe how you've seen this decarbonization conversation change in the last 2 to 3 years. Or maybe it hasn't changed.
Well, I have observed, because I attend a lot of events, I have observed a bit of a shift in the conversation, and I think as a society, we have begun to come to grips with the other side of the balance between goals and cost. And I'm seeing cost and reliability in the conversation more and more, and that just drives the need, I think, as Hohl mentioned, for modeling. As we look at these inverter-based resources that have no inertia on the system, and we don't know exactly, as you said, Alice, exactly where we're going to end up in a few years, we really have to be able to use our very best thinking about what the scenarios look like, what the system could look like, and that affects everything we do: planning, engineering, construction, and operation.
And Alice, you could Monte Carlo simulation, yes, that's, but relate that to that background. But now that's deeply tied to how Xcel is approaching this decarbonization equation, probably much different than 10 years ago.
Oh, absolutely. When you think about the generation side of the business, which is really what you're looking at, is the resource adequacy. Do we have the capacity and do we have the energy that's necessary to serve our customers as we move forward, particularly as we are adopting variable energy resources on the system? Not less than probably 7 years ago, for a number of utilities, when you went before your regulator, or if you didn't have a regulator because you were a municipal or a cooperative, when you looked at your load and resources table, you were really evaluating 1 hour. You were sitting down and you were looking, what is the peak consumption that my customers are going to have on the system? Do I have enough generation and capacity in order to meet that peak? And then you were good the rest of the year. Life was wonderful. It was nice and simple out there. Now we have to look at all 8,760 hours in a year. But it's not good enough anymore just to look at the 8,760 hours in a year. Now you've got to look at weather patterns that can vary for every single one of those 8,760 hours a year. Because like in Colorado, my jurisdiction, we're a 7,100 megawatt peaking system. I have over 4,000 megawatts of wind on the system, and I'm adding another 2,000 megawatts to that in the next 2 years. In addition to that, I have over 1,500 megawatts of solar, and I'm going to be adding another 2,000 megawatts of solar to that as well, plus another 1,800 megawatts of a battery storage installation. All of those things have characteristics that are very different than a combustion turbine or a combined cycle or a gas plant, a coal plant, or a nuclear facility, right? They behave very differently. I've yet to find my bat phone that lets me call God and say, hey, I need that wind to blow a little bit more. Could you keep the sun up a little longer today? And so those are the kinds of things that we have to now take into account in our modeling. It's every hour of every day under multiple scenarios. And that's where kind of the Monte Carlo simulation comes into account. Is when you think about it, you sit down with your financial planner, typically once a year, maybe a little bit more frequently if you really like to keep your eye on your investments, and you're looking at your retirement. And they run Monte Carlo simulations that sit there and go, what are all the different permutations that might happen to give you confidence that when you retire, you're going to be able to live the life you want to live? We're now starting to look at how do you apply that to these scenarios for resource adequacy. How do you build enough of those weather patterns or load consumption patterns that you go into the future that when you pick the capacity that you're looking at, and you pick the energy profile that you expect from it, that you have a high probability of confidence you're going to come out the other side with a system that operates well. That we see as a very necessary element of moving forward because of the variability and the uncertainty that we're injecting into the system deliberately with choosing the resources that we're choosing today. So really it's about hitting the right confidence level of what it is that we're investing in to make sure that we can continue to provide the services for our customers. You add that to some of the stuff we saw this morning. ERCOT was up here talking about some of the load forecasts here in Texas. It's not unusual to see that in all the other jurisdictions as well. The data centers that are coming in, the electrification of transportation, looking at people potentially converting their home heating or businesses from gas to electric. Those are all going to drive factors in the future that are very different. Load factor is a huge conversation on the system, and we can get into that on how that impacts distribution and transmission. But there's a lot to this that we have to look at. So having those variety of things to look at in the Monte Carlo simulation type outcome is really going to help us look at the probabilistic outcome of can we serve our customers.
Fantastic, and just thinking differently, applying new tools to some dynamically changing situations. And Emeka, can you maybe talk a little about where Lincoln is at on that journey and how you guys are thinking about that?
Yeah, so I mean, I always find this to be a really interesting conversation because when you look at, again, my colleagues here have been alluding to this, there's sort of a lot that goes into this. Our utility happens to have, and now obviously there are various permutations of these decarbonization commitments. Ours is a 2040 goal for net zero from our generating fleet. So we operate just shy of a gigawatt of generating resources, basically, that we variously sort of own and operate and are partnered to own and operate. And we're about a third across the board. So about 1/3 natural gas, about 1/3 coal, and about 1/3 renewables, which is mostly wind. We have a little bit of solar that we kind of have locally. But what's interesting about all of that, of course, is that as you look at what's going on, we are, our climate action sort of projections are showing about 5 degrees warmer on average in Lincoln by 2050. Okay, we're looking at numbers that are, 10 to 16% increase in precipitation. Something like, 15 to 30% of sort of what we would call high precipitation days, right? And for me, obviously, as kind of a grid engineer by background, high precipitation days typically means, lots of other sort of weather, obviously, sort of impacts to the system, right? So all of these things are happening even while, when you look at, and, we have a similar thing going on, obviously, across the Midwest, where we are seeing this penetration of new load around data centers and all this other stuff, Interestingly enough, because the grid engineer in me couldn't resist, when I was looking at the numbers from ERCOT, one of the things I observed is, when you look at those numbers and sort of how the percentages change, what's actually true is, something like, from a coal retirement perspective, those numbers translated to something like 35 or 40% reduction in coal. The natural gas retirements, almost nothing. What's actually happened is the load has gone up. And one of the things that we have seen, of course, from a resiliency perspective is we are starting to reckon, right? So, ERCOT has seen this. We're talking about it in SPP where LES is a member. We are starting to see sort of these realities present themselves, the limitations at times of what we would call, quote unquote, traditional resources. It simply isn't true that you can sort of, if all you did was stand pat, stop all the retirements, stick with the sort of the combustion turbines we've been used to, and the resources we've been used to, that's good enough, right? We are seeing the limitations on fuel systems and fuel supply. We are seeing the weather impacts of things that we've not previously sort of contemplated. And so, this layering on of new resources, both renewables that we're seeing at scale, but also all the new technologies, is critically important to the resiliency conversation. There is a role for all of these, what I will call sort of fuel-saving renewable technologies that allow us to extend beyond the limitations of our existing fueling systems as well.
Thank you there. And Alice, and maybe just building off that, because I think everyone's mentioned just a lot more, not just capacity coming on. There's different types of capacity, but that also means new nodes and sensors, and then it comes back to data, right? And then I think you had mentioned earlier of your background, right? Being in having that early background, but also that also fundamentally changes the type of workforce maybe you're creating to be able to handle this situation. So maybe expand on that piece and tie it into data and how that's a key piece of the puzzle there.
Well, I believe data is critical to our successful future, not only in building the analytics around what should we build, but then in operating it as well. If you're sitting in a control room today that dispatches generation, not only do you have a lot of screens that you're looking at, but you have to make decisions on which assets are going to be available days in advance. So when you think about the predictability and the data that we have today, in order to inform those decisions, we have to continuously look for ways to improve that data. I go back to the history. In 2004, in the state of Colorado, for example, was when the ballot initiative came out and the good people of Colorado voted to put in the first constitutionally based renewable portfolio standard. At that point in time, our utility was opposed to that particular standard. And the reason was very well founded for two reasons. Cost. The wind energy at that point in time was well more expensive than the natural gas or coal-fired generation we had on the system, so it was going to increase costs to customers. And variability. When you think about what a utility is compensated to take on, risk is not in the top 10. Risk is not in the top 20. Risk is not something utilities are typically compensated to take on. So when you throw variability into the mix, it becomes a problem. It becomes something that we are reluctant to take on. But the good people of Colorado said, you need to do this. And so when your customer asks for it and you're told to go and look at it, you start looking at it. But who do you call in? You call in the experts. You call in NREL, you call in NCAR, you call in the other people that can give you information. So we then worked with them to build one of the best wind forecasting tools that is now used around the world and by many utilities in order to close the gap on the risk that you were facing. That doesn't mean it's perfect. It doesn't give me 99% accuracy, it gets me to about 65. That's the data that I have coming in, right? Then you look at the solar that's coming on the system. In order for us to decide that we're going to turn off the coal plant or the natural gas plant or things like that and go, okay, it's going to take us 48 hours to heat, the coal plant once it's cold, and it's going to take us 24 hours maybe on the combined cycle, but maybe only one, on the simple cycle. Those are things we have to take into account. So you're sitting there with all this data. Now let's add in the customer element. We're now looking at adding customer participation on a real-time basis into ancillary services and operating our grid. If we think about this long-term where things need to be, we have to have a much more symbiotic relationship with our customers because closing the gap on that last 5% of what we're going to meet with zero carbon energy, we need them to meet us at the table. We need them to come and join us and help us match the load profile to when the energy is actually available. So in order to do that, you have to have data, once again. You have to have visibility, you have to have communications, and you have to understand people's willingness to actually vary their consumption. That's orders of magnitude more data on our system. And we haven't even gotten to talking about the topology, the GIS, and all that other information that we need in order to make sure that we're managing things well. Because when you have not just, let's call it 25 generation assets on your system, but you have hundreds of thousands, maybe even millions, depending upon the size of your company, that's a lot of data input that has to come in and simultaneously be solved in order to keep the frequency of our grid operating. And I dare you to ask any grid operator if balancing the frequency of the grid is an easy thing. I bet you will never get a yes.
Wow, good stuff there. So Pat, that's an interesting conversation there because so much data, you had mentioned ESRI is basically covered nationwide, almost globally. And how are you guys handling that? I mean, to be able to keep up not just with the demands, but new devices and all that, and keeping the technology able to provide the information utilities need to make these decisions?
Yeah, that's a great question. Emeka, I didn't realize that you and I had such similar backgrounds. But as we think about data, I'm sure you were in this same position. At many points in the past, I had to integrate the data in my head, right? The union work rules, the weather forecast, the current load, the current temperature, all these things that had happened. And so what we're seeing today is the ability to bring those kinds of data together. And if I was to ask you, what is the first word that pops into your head when you think of GIS? Everybody would say maps. But really, I challenge you to think that maybe it's about discovery, because part of that research that ESRI has poured into the platform in the last decades has resulted in the ability to ingest all kinds of data. Of course, geographic data, but big data, little data, spreadsheets, imagery, all of these things are now being brought together. And some of those forms of data, they feel like they're not relatable, right? You're a data person, Alice. You need a unique key to bring this data together, right? And what I have learned, and one of the reasons that I enjoy working at ESRI is I've come to this understanding of how everything that we care about has some location. Right? The customer has a location, the renewable resource has a location, our equipment, our personnel, our customers, they're all someplace.